Hello students, welcome to the next session, lecture number 16. So in this session we'll be discussing commutation circuits. As we had discussed in the previous class, commutation process is nothing but the process, the way we turn off the SCR or the thyristor in a circuit, right? So the circuit that you use to turn off the SCR is nothing but commutation circuits, and the components that are used in the circuits that will eventually help to turn off the SCR are called commutation components. Okay, generally they are inductance and capacitance that will be used in order to turn off the device or the SCR or the thyristor. Okay, so when we say turn off, what is turning off the device? As we had discussed in the previous classes, in order to turn off SCR or the thyristor, we have to bring the anode current that is passing through it below the level of holding current, all right, and the reverse voltage has to be applied to the device so that you will turn it off, right? So bringing the current to zero and sufficient time, the reverse voltage is applied to sufficient time so that removal of charge carriers takes place, right? So please go through the previous sessions what we have already discussed in the previous sessions. Okay, so by the end of this class you will be able to describe the class A and class B commutation circuits of an SCR. All right, so as I mentioned, in the commutation circuit the commutating components L and C will be used. All right, so if you recall again, the commutation process, there are two types, natural type and forced type, natural commutation and forced commutation. If you recall, in natural commutation, we use the AC supply, the input supply itself, as as a means to turn off the device, right? Whenever the input voltage crosses zero, and when it is in the reverse direction, then that itself will be turning off the SCR in the circuit. All right. So if your supply voltage is DC type, then you have to go for this forced commutation method, wherein you will be using external circuit, wherein in this external circuit you will be using commutating components, that is L and C, eventually which will be helping to turn off the device, right? So before moving on to our actual class A and class B, let us understand what happens when an inductor or a capacitor is connected in a circuit with the DC supply. So there is an animation here which I have used from YouTube, uh, which will help us to understand its working. All right. So when we have an inductor or a capacitor connected with the DC supply, to understand it, let us first understand both the components taken separately. Okay, let's see what happens when both the components are used with the DC supply. When we connect inductor with the battery or a DC supply, current flows in the circuit, but the rate of rise of current is not instantaneous. It does reach the maximum value but takes some time. Okay, and in the process it stores energy in the form of magnetic field. When a capacitor is connected with the DC supply, we know that we say capacitor blocks DC, but before that happens, the capacitor allows the current to flow in the circuit and stores energy in the electric field. So the voltage across capacitor will be increasing. Okay, so the capacitor charges to the level of the battery in the circuit. Okay, so when there are both the components connected with the DC supply, both will be storing energy in their respective fields, inductor in the magnetic field and capacitor in the electric field. Okay, so there is a point where the capacitor charges to the battery level and current reaches maximum value. That is when current actually stops flowing and current has to drop to zero. But because of the presence of inductor in the circuit, this will not happen instantaneously. Current will reduce slowly and inductor acts as a voltage source and starts driving current in the same direction, and the value of the current eventually drops to zero or becomes null. So in this process, the capacitor charges to a higher value of voltage, that is twice the value of the DC supply. So when the inductor and the capacitor are connected with the DC supply, the capacitor charges to twice the value of the supply voltage. All right. So with this information, with this knowledge, let's move on. This is our class A commutation circuit. So if you observe that you have the inductor capacitor connected in series with the load, and you have SCR connected in series with the LNC component. So if the load used in the circuit is of lower value, then generally we will connect load in series with the LNC with the SCR or the thyristor. If load is of higher value, then generally load will be connected in parallel in this fashion as shown in circuit B. So this circuit we call it as underdamped circuit, which means that current in the circuit eventually drops to zero, and slowly it decays. Okay, that is nothing but underdamped circuit. So the components LNC used here will be turning off the SCR, is switching off the SCR on and off. All right. So let us observe how it works. So with the information of LNC, what we just now discussed, you might be now in a position to understand. Initially, when the SCR is turned on, the capacitor charges to the VDC level, all right, and once the capacitor voltage is equal to VDC, then that is when the current in the circuit will be stopped, right, and the inductor then reverses, okay, and acts as a voltage source. It reverses, so the polarity of the inductor will be plus here and negative here. So if you observe, the negative potential now of the inductor will be connected to the cathode, so which will be connecting SCR in the reverse bias condition. All right, and the current will be dropping, right? Current in the circuit will be dropping. Eventually current in across the SCR also will be dropping. So the energy from the inductor will get dissipated to the capacitor, and capacitor charges further, right? All right. So once the SCR is turned off, once current becomes zero, SCR is turned off, then the capacitor will discharge via load. Okay. So that is what is explained here in these points. Just now what I have explained is put across here. The value of LNC are selected in the circuit such that the circuit is underdamped. The current attains zero value at point A as shown in figure B. All right. As SCR is turned on, the charging of the capacitor is done through the supply voltage VDC. We know that. The polarity of the capacitor is shown in the figure. If you observe, okay, that is how it is getting charged. Okay. When the capacitor voltage charges up to VDC, current passing through the inductor now reverses. Okay. So when it reverses, as the inductor current becomes less, the holding current of the SCR less than the holding current, the SCR turns off. Okay. So this turning off time, actually it depends on the values of LNC, the commutating components. So if you observe the waveforms here of class A commutation circuit, observe, we'll be checking the response with respect to input. So the input will be our gate current that we apply at the gate terminal. This is a voltage across the capacitor, current across SCR, and voltage across SCR. Let us observe what happens. All right. So the moment you give the gate current, SCR turns on, right? So when SCR turns on, the current in the SCR starts rising, right? So when the current is rising, observe the voltage across the capacitor. Voltage across the capacitor also is increasing. So when the current in the circuit is maximum, across SCR is maximum, the voltage across capacitor will be at this point, right? So that is when now the inductor will reverse. Will reverse, okay? When the inductor reverses, it is dissipating its energy to the capacitor, charging the capacitor further, and the current in the SCR is now dropping. Okay, so it drops to 0. That is when the SCR will turn off. Okay, if you observe the voltage across SCR, when the SCR is turned on, the moment it turns on, the voltage across SCR is minimum. All right, and when it is turned off, the reverse voltage is applied in order to remove the excess charge carriers, right? So this is the turning off time period of the SCR. Observe there is no current across SCR at this point. Observe the voltage across capacitor there. Now in this stage, when the SCR is turned off, capacitor is discharging via RL. Correct? So these waveforms show us the working of class A type of commutating circuit, wherein commutating circuit you are using LNC there, all right, and the process of turning off your SCR or your thyristor, the way you are turning it off, right? So this turn off time period, it depends on the values of LNC that is used in the circuit, that will be used in the circuit. Correct? Okay. So moving on. Next, the class A commutation is also called self-commutation, as you know, because the circuit itself will be turning off the device. There is no external circuit required there. And mainly this type of circuit is used for 1 kilohertz frequency, and the cost of the circuit will be mainly depending on the rating of the LNC that will be used. All right. So moving on with the class B commutation circuit. This is your class B commutation circuit, wherein if you observe, SCR is connected in parallel with the commutating components, whereas in class A, SCR was connected in series with the commutating components. All right. So observe here, initially when the SCR is not turned on, the current in the circuit will be flowing in this path, right? VDC, C, L and RL. So this will be the current path. Okay. So that will be charging the capacitor, isn't it? So in this path of the current flow, the capacitor will get charged. All right. The moment you turn on the SCR is turned on, say after some time. So when the SCR turns on, the current in the circuit will be now this, okay, that we call it as IL. So from VDC via SCR, the load, the current will be flowing in this direction. So at that time, what happens? The capacitor starts discharging in this path. Okay, capacitor is now discharging. Once the capacitor discharges completely, because the SCR is already on, what happens? Now, because of the SCR, the capacitor gets charged again, but in the reverse direction. Now, the lower plate of the capacitor will be positive and the upper plate will be negative. So, when the capacitor is getting charged in the next cycle, all right? So, capacitor will get charged via SCR. So, after some times, what happens? Now, capacitor has to discharge, right? All right. So, the current of the capacitor now will be in this direction. So, with what is happening there? Current because of the capacitor will be flowing in this direction, which is opposite to IL. So, that will be turning off the SCR. Okay. So, because of this capacitor charging and discharging, the SCR will be switched on and off, okay, using this commutation circuit. So just to put that across in points, the commutating components L and C are connected in parallel with the SCR in class B type, as I just mentioned. So when SCR, that is T1, is turned off, the charging of the capacitor is done through plus VDC plus C minus C, L, RL and VDC. That is plus VDC plus C minus C, L and RL and minus VDC. This will be the path. All right. When SCR is turned on, the load current flows through path VDC, T1, RL and VDC minus. When SCR is turned on, the current path will be in this direction. All right. So as soon as SCR is turned on, the discharging of the capacitor is done through plus C, SCR, L, C minus. Okay. Plus C, SCR, that is T1, L and minus C. In this path, the capacitor will discharge. So therefore the load current as well as capacitor discharging current flows through SCR in that stage, right? So once the capacitor discharges, it will again charge with opposite polarity, as just now I mentioned. Therefore, the commutating current IC flows in opposite direction to that of the load current. So when this capacitor current is greater than the load current, the SCR will be turned off. So as the SCR is turned off, the charging of the capacitor is again done through the same path, initial path, what we had there, this path. Alright. So that is how this class B commutation circuit is used to turn off the SCR. Alright. So the SCR automatically turned on and off in class A and class B commutation circuits. That's why they are also called self-commutation. Whereas class A is also called resonant commutation circuit. All right. So this is about commutation circuits, class A and class B, which is used to turn off the SCR in the circuit, which will be eventually switching the SCR on and off. All right. So based on the values of the capacitor and the inductor, the turn off time can be designed. All right. Based on the ratings that will be used in the circuit. So please go through the session recording again and again in order to understand this. Okay. That's about this session. If you have any doubts, please get back, go through the video recording, understand the commutation process. What is it? So to understand what is turn off, again you should know what is turn off characteristics. Then you will be able to understand the turning off circuits, that is commutation circuits. So you should know the two types of commutation methods, that is natural and forced type. So you should be able to differentiate them, what is natural type and forced type. So in forced type, you have class A, class B, class C and class D. So for your syllabus, you have class A and class B. So that is what we have discussed. There is design consideration here in the textbook, but I don't think so that is given for mentioned in the syllabus. It's not mentioned in the syllabus regarding the design specifications or the consideration. So we'll just limit ourselves to the theory part of it. All right. Kindly go through. If you have any doubts, please get back to me. Oh,